So the complement principle is just like working with complementary angles in geometry. If we look at these two angles here, we see A is a subset of universal set U. U is kind of like our 90 degrees here. So if U represents our 90 degrees, then the element of A is basically taking the entire 90 degrees minus whatever's not A, 30. Or the other way you can think about it is A plus not A equals the entire 90 degrees here. That's the universal set. Let's take a look at the next one here. If you have 5 signal flags and can send messages by hoisting 1 or more flags on a flagpole, how many messages can you send? Well, let's see. If we have 5 flags, then we have 5 spots. 2, 3, 4, 5. And how many options do we have in our first case here? Well, we haven't used any flags, so we have 5 options there. But then one of those flags gets used up, so that must mean that we have 4 flags left to use for the next spot. Then one of those flags gets used up, and now we have 3 flags available for this spot. And then one of those flags gets used up, and we have 2 flags available there. And then the last one, we have 1 flag available. So we have 5 times 4 times 3 times 2 times 1 means we have 120 ways of doing 5 flags. If we do the same thing for 4 flags, then we have 1, 2, 3, 4. Again, we have 5 ways, then 4, then 3, then 2. So 5 times 4 times 3 times 2, that'll also be 120 ways. Or you can have 3 flags up. You don't need to have 5 or 4 flags up, you can have 3. So if you have 3 flags up, you have 5 options, then 4 options, then 3 options. So that gives us a total of 60 ways for having 3 flags up. If you have 2 flags up, you have this case as well, or, so we have 2 flags up, we have 5 possibilities in the first case, and then 4 possibilities in the second case. So that gives us 20 flags, or 20 ways of doing 2 flags. And then we also have the option of 1 flag. And if you only have 1 flag, then, well, you only have the 5 ways. So if we have 5 signal flags, how many messages can we bring up? Well, we're just adding them all up. 120 plus 120 plus 60 plus 20 plus 5. That adds up to 325 ways. Make a tree diagram for flipping a coin 4 times. How many possibilities are at the bottom of each row? How many will be on the last row after 8 flips? So the first time you flip it, it either becomes heads or tails. So on flip number 1, you basically only have 2 ways. Then once you flip heads, you have the option of getting heads or tails. Or if you flip tails, you also have the option of getting heads or tails. So on the second flip, it looks like we now have 4 different ways. We have 2 squared, which is 4 ways. If you flip it again a third time, heads, you can flip it again, you can get heads or tails. Here you can get heads or tails. Here you can get heads or tails. And here you can get heads or tails. So on flip 3, we have 1, 2, 3, 4, 5, 6, 7, 8 different ways. 8 is just 2 to the 3rd power. So we have 8 ways of, or 8 possibilities when we flip 3 times. You flip it a 4th time, and again you have heads, tails, and we just keep repeating that for each of the possibilities. And I'll just draw lines to make this quicker. So it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 ways of, or 16 possibilities on flip number 4. So that's 2 to the 4th. That would be the same thing as 16 ways. So we see this pattern here. Basically, we're just taking it to the power of the number of flips. So if we want to find out how many possibilities will be after 8 flips, that's just 2 to the 8th. And that's the same thing as 256 ways. Number 9, how many different ways can we select a president, vice president, and treasurer for our class? Assume there are 30 students. So if we have president, vice president, and treasurer, we pick a person to be president. And if we have 30 students, well, there are 30 possible people who can be president. But once one person is taken out and put as president, that means vice president only has 29 options. And then if there's only 29 people there, one gets taken out, then a treasurer only has 28 possibilities. So if we want to find all the different ways, it's basically multiplying these together. 30 times 29 times 28, and we come out with 24,360 ways. Number 10, this one's a little bit different. How many ways could we select 3 people to represent the class on a school committee? So there's no longer the role of being president or vice president. If you're on a committee, everyone's just in one group. So think of like a leadership class, minus the president and vice president and treasurer. If you just have a bunch of people helping out, then it doesn't matter whether you have A, B, or C, because that's the same thing as A, C, B. And even that is the same thing as doing B, A, C, and that's the same thing as doing B, C, A. It's all the same 3 people, but they're just in different orders. But the order doesn't matter since we're just on a committee. Just kind of finishing this off, we also see that we also have the possibility of CAB or CBA. So that's just a small case. But if we were thinking about our class of 30, what we have is that if we want to fill 3 spots, there's 30 people available in spot A. Take one of those people out, and then you'll have 29 people available in slot B. And take one of those people out, and you'll only have 28 spots available in spot C. But what we notice here is, just like the president, vice president case, we end up getting repeats. If we're choosing 3 people, we see the number of repeats is 1, 2, 3, 4, 5, 6. 6 repeats for the same amount of people. So we're really dividing this by 6. 6 is made up of the pairs or the groups of 2 that are repeats, and we have 3 of them. So we're going to divide it by 6, which is really 3 times 2. So 30 times 29 times 28 divided by 3 times 2 means we are only left with 4,060 ways. A lot smaller than our previous case with the president and vice president. If this looks familiar, it should, because this idea that we're dealing with here is working with combinations versus our previous case, which was working with permutations. In permutations, notice here it does matter whether you're president, vice president, or treasurer. With permutations, order matters. And with combinations, order does not matter. Okay. If you can recall the formula from back when you were working with this, combinations, or let's actually work with permutations first. The permutations formula is where we say the number of elements that we're working with, taking the permutation, and we're choosing our number of things. So NPR is equal to n factorial over n minus r factorial. In the combinations formula, we have NCR, the number of elements total, and we choose our number of things, is the same thing as taking your n factorial divided by r factorial times n minus r factorial. So the only difference here is what you notice, this was really just your permutations formula right here, and you're dividing it by the r factorial, like what we did there. That's turning into a combination. And that's it.